Hello, everyone. We're going to start the session now, and we're going to talk about implementing real-time security actions using transaction security. Just a quick head count. How many people have used Salesforce Shield? Right. How many people have heard about it? All right. That's great. Few people have used it. All right. So before going forward, quick introduction. My name is Pura Kashyap. I'm a senior software engineer with Salesforce. I'm on transaction security team. And
I'm Aditya Rawat, and I'm representing Cisco Cloudlock.
right, before moving forward, we're going to talk about a few roadmap items and a few pilot features. So please make your buying decision based on what is available in Salesforce in general. So if you're a developer like me, you have your product managers that come to you with all these great requirements. And when these apps get to production, when they get to the cloud, you have these users, they're contributing to the usage of your app, and they're generating a lot of data. Data could be sensitive information, and that needs to be protected. For the sensitive data and protection of this data, you want to create trusted app. And trusted app is not like one silver bullet. It's not one short solution. It is a multifaceted problem, and the key attributes being privacy, transparency, security, and compliance with industry and government standards, right? And also in the implementation part, there's no one technology involved in building such a trusted app. You'd have to look at password policy, identity, encryption, setting up roles, permissions, and so forth. So how do we monitor and control the behavior in user time? So think about this. Once you have all of this set up, you would like to monitor the behavior of your trusted app. You would like to audit it, look at different anomalous behavior. You could set up your in-house tool where you can look at these anomalies. But wouldn't it be too late for you to take an action at that point? The anomalous behavior has occurred. So that's where the question comes in. How would you monitor these behaviors in real time? And Salesforce, by the way, has trust built in every layer, starting from the infrastructure, network services, and applications. We have a product called Salesforce Shield, and the key technologies that are involved in Salesforce Shield is encryption, event monitoring with transaction security, and audit trails. So going into the event monitoring, which is with transaction security, the topic for today is there are two parts in event monitoring. One is ability to look at your org's usage using analytics engine. And the second part is ability to take real-time action using transaction security. Without further ado, since I'm a developer on transaction security, very happy to talk about transaction security right now. This framework allows you to monitor user activity. You can intercept in real time and take an action. It's easy to set up with few clicks, some code, or you can use Cloudlock's framework to do it in just one click. So just to set a roadmap, what we'll be talking about moving forward, I'm going to take you through an example. And then we're going to write a transaction security policy, see the policy in action, and then I'm going to talk about architecture. What are the different components involved in transaction security behind the scenes? And then hand over to Aditya so he can show us an awesome demo of what Cisco Cloudlock people are doing. So here's our use case. So what we want to do is we want to limit the number of sessions a user can have to n, right? And a quick question comes to my mind. How many times you click on the log out button? When normally people go, log in, do what they want to do, and never click on log out button. They just move on to the next thing. So what happens over time, you have so many sessions that are live, and they're not terminated. So, and this happens to be also one of the US FedRAMP requirement, limiting the concurrent number of sessions in order to mitigate the risks with malicious software. So in the end, your policy should enforce the users who will be impacted. They should see a screen where they can click to terminate their previous session before getting a new one. So the first step for designing such a policy would be analyze what you have today. What is your baseline? Who will be impacted? So look at the profile. Look at the users who are from different roles. Right. Second part would be if you have any integration in your organization, could that break? Third would be you would like to know what are your current, where are the people actually coming from in your organization? Are they coming from the web browsers or S1 app or any other integration? Once you have determined that, let's go to Whiteboard. Let's determine the criteria for your policy. System admin seems like a very powerful profile. It has a lot of root-like privileges. That could be a good profile to create this policy on. Or you could go by the role, East Coast versus West Coast executives. Else, you could go by the users, Purak or Aditya. You might want to block by a specific user. Or in general, you can say my organization operates during the weekday. If somebody is trying to log in during a weekend, that's a bad behavior. So once we have determined the criteria, next thing for this policy, we want to determine what action we want to take. So there are a couple of actions that are available out of box with transaction security. Block action, that is just clearly blocks the users from logging into your organization. If you want to bump up the session level, you can do two-factor authentication, right? And if you just want to do notification, choose the none action. For the purposes of this demo, we're just going to choose end session to log in. So now moving on to the part where you have writing, you determine the criteria, now you're putting that criteria into Apex code. Here, in this example, we're trying to say if your profile is system admin and you're trying to gain the second session, this policy will be triggered. And that's denoted by returning true here. And if there is some other user other than sysadmin who are trying to come in, and if they're trying to gain the fifth session, that will return true. Okay. So before moving forward, there are other examples just like this. Feel free to click a picture here. There's an Apex guide that you can refer back later on with all these policies. So next question would be, you have created the policy, you have a good understanding, now you want to enable this policy in production. It's as easy as going to the UI and clicking on enable. That will enable the policy. There's one quick note though. Before you enable the policy, make sure you test it out. And some scenarios could lead to lockout of your organization. So you need to be aware of those things based on your criteria. So how does it look like in real time when this policy is being enforced? Your users, when they're trying to log in, they will be taken to this UI page that's going to offer them a choice to end the session, a specific session, and to proceed forward in order to gain the new session. And then to complete our cycle of analytics, we'll also have an analytics log line that you could see in your event monitoring. So moving on to the architecture, behind the scenes, how does transaction security work? On the left side are your customers. They're trying to do login, data export, entity and access operations. Transaction security handles all these events, grabs your policy definition that you have defined, and then applies that policy on top of that event and passes on to the action handler. Action in our previous example was end the session to log in. So this was the action that will be implied by the action handler. And after everything has been done, we'll also log a line to the event log file so that you can also analyze it. So it's a good question. We have talked about login event. What other kind of events are available for you to create policy on? Customers create policy if you want to do, let's say, write a policy on chatter based events. You can use entity event. Data export is a very popular event which lets you create policy on report export and dashboards. Other events that are resource access, if somebody is trying to access using connected apps, you can write a policy. And the last one, the user permission event, is going to become pilot soon, which will enable you to write policy when somebody is trying to access platform encryption setup page. And just a quick note here, if somebody thinks they have a use case that should be part of Salesforce transaction security events, please come to me after this presentation, hand me your business card. I can give that to our PM, Yari. So without further ado, I'm going to hand over to Aditya and see how Cloudlock is using transaction security framework, and then we'll go for a demo too, right?
Thanks, Puruk. The architecture was pretty cool. So, hi everybody. I'm here representing Cisco Cloudlock today. And who are we? Cisco Cloudlock protects the usage of apps and infrastructure in cloud. We are 100% cloud native, as much as so that we run ourselves on AWS. That means no hardware, no proxies. We do so by UBA, which is user behavior analytics, which essentially is detecting anomaly in users' behavior. The second is DLP, data loss protection, which primarily is about analyzing what kind of data you have currently in the infrastructure and taking action against sensitive information, whether it's social security or credit card numbers, encrypting them for compliance perspectives, or preventing any malicious data exports. And lastly, the apps firewall, which essentially is analyzing the scope access of the connected apps. So like many other people, we are using Google or other platforms as identity management. Apps firewall can check what all permissions do these apps have and take action based on any violations. So our current offering on Salesforce, which either complements or extends the Salesforce Shield, I'm going to start off with selective encryption, which essentially is encrypting or moderating sensitive information, which may be CCN or credit card information, which could be either in records, even fields, or files uploaded to the Salesforce platform. We can detect the insensitive information, encrypt for compliance or data security purposes. The second is event monitoring viewer, which is a parser around event log files. And what it does is it basically provides analytics on what call events are happening on your Salesforce platform. And this is also fed into our user behavior analytics engine, which allows us to detect anomaly against any action that takes place in the Salesforce platform. And lastly, the transaction security, which is the first ever in-band security, which allows you to take real-time actions within Salesforce. So why in-band security? Well, taking a real-time action within Salesforce is huge in terms of the security standpoint. Cloudlock's technical opportunity here is to detect anomalies in the user behavior and inject intelligence within the real-time actions taken care of by the transaction security. Instead of businesses trying to write their own logic into Apex classes, which constitute of a transaction policy, Cloudlock can provide a turnkey approach by dynamically implementing policies, taking a cross-platform or cross-cloud security into perspective. When I say cross-cloud, what I mean is we can detect anomaly in other platforms that you may be using and take action within Salesforce if we find a compromised account against a user. So a little bit of architecture, how we built a framework on top of transaction security. So first, Cloudlock user behavior engine detects any anomaly within the user's behavior. If there's an anomaly, it results into a violation. And in case of violation, we take action using the transaction security. So I'm going to talk about a little about the approach that we took in terms of implementing transaction security. Not all policies should apply to all users. What we did was we created, as an example here, is a payload that manages users and applies policies when needed. If there's a user that has been found in violation, we apply the transaction security policy real time using the security endpoint. Why APIs? Well, APIs allows us to rapidly analyze data and events within the platform, and there's no impact on users' experience. Now, without further overloading you with more information, we're going to do a live demo of basically everything what Purak and I spoke in action. So I'm going to exit out of the presentation here. And what I have is a Salesforce instance. I'm going to log into my instance here just to make sure everything is working as expected. I have a report here. And I'm able to export all reports, all fine. Until my accounts get compromised. And just for the sake of demo, let's imagine the bad guys are sitting in China, maybe. So to mock that, I'm going to use the VPN, which will kind of mock our location from Shanghai, or Hong Kong in this case.
Right. So this is one of those criteria that we talked about earlier, the geographical location where the users are coming from. If your organization is based in a certain region, this the Cloudlock's policy solution provides you the ability to perform transaction security actions based on that.
So looks like I'm successfully logged in from Hong Kong here. Now I'm going to log in again from Hong Kong into my account. So what we just did here is we had a login from an offsite location, here in this case, Hong Kong. And a few minutes ago, I was just logged in from a US location. Now, Hong Kong is about like 10 hours away if you take a commercial flight. There's no way you can be in Hong Kong within a few minutes. So that, in this case, what we're doing is we're generating an anomaly in users' behavior. So I'm going to log into our platform here, which should raise an incident about this behavior. So this is our platform here, and sure enough, it's just 1 minute ago, I logged in from an offsite location, Shanghai, which kind of intercepted it, showed it as an anomaly, applying the transaction security as a response action. So what happens here is now, with my login, I'm blocked from exporting any more data.
Right, and add to that, this is the message when the policy gets enforced. This is how users see that the policy has been enforced. And Aditya has also chosen, I believe, to get also notification. So
yeah, so as soon as a policy is implemented or transaction security takes place, it shoots out an email. It can be your manager, your admin, just to notify them, hey, there was a security violation.
Right.
So yeah, that was pretty much the entire transaction security, in action, along with the user behavior anomaly. So yeah, few years and years while we were developing this framework on top of transaction security. So I'm going to talk about some of the good points. Yeah, so first ever in-band security within Salesforce. It's very robust and reliable. We've been testing it extensively, and at no point we found any event slipping by. It has a fantastic documentation, very good job in part of the team here. Highly recommend the Trailhead on transaction security, which can get you up to speed with this feature in few hours. And a little bit of the downside here. So right now, the transaction security, you can only take blocking action against custom objects and events. So hopefully, I should say standard objects and events. And hopefully, we should be able to take blocking action against custom objects soon. And the second point, for those who were paying attention to the Apex policy, I have a screenshot of the Apex class here. And what we have is an event E, and it basically contains data of all the information of the event that just took place, except the blocking action that's supposed to be taken in case of that event. So what that means is, let's say you have the same logic, and if you want to implement 2 different blocking actions, you have to pretty much duplicate the code for a separate blocking action. And lastly, no DMLs are allowed, so you can't, pretty much you can't like report on it, generate reports on how many events were taking place. So that was something I found was a technical limitation in terms of doing a DML. But yeah, apart from that, pretty good job there, guys.
All right, thanks. Okay, I'm going to go over a few more things. Aditya mentioned Trailhead. In general, for Salesforce Shield, we have a couple of Trailheads. I think it's a good way to learn a product, take that Trailhead unit, spend, I think it's approximately 3 hours. That will take you, all 3 units. I think, and you'll earn some badges and bragging rights. So one other sessions that we are having on event monitoring, really, a shout out to them. It's going to happen tomorrow, 2:15 p.m. in the Frontier Theater, 5 p.m. Amanda. So we have spoken enough about what the framework is, what solutions are available for the framework. You guys have any questions that we can answer? Right?
The examples that you showed at the beginning, such as the analytics of logins and the various events that you could control, were that only for Shield or event monitoring, or is that available in standard too?
So the question was, the analytics example that I showed earlier, is that part of Salesforce Shield? Is that correct? Yeah. Right. Yes, that is part of Salesforce Shield.
And the same with the various events that you would control in Apex? Can those be done only when you have Shield, or can they be done?
Yes, right. They are, so all the events that I talked about, apart from login, like entity, access, and other so forth events, are available as part of Salesforce Shield. Right. Anybody else has any question? All right.
Thank you, guys.
Right. Thank you, everyone. If you have any other questions still, come talk to me after this. Right.
Thank you.